Hi, welcome to my session. My name is Shakil Ahmed. I'm one of the senior solutions architect based out of Melbourne, Australia. And today we'll go through some of the best practices for connecting your workloads in AWS. Let's start with connectivity within your AWS environment today. So imagine a customer who currently have single VPC in AWS with some public resources. It may be load balancers, it may be NAT gateway, with some private backend services or databases workloads today. Now, within a VPC, to ensure high resiliency, we highly recommend using multi-availability zone architecture and ensuring that the critical workloads are replicated across multiple availability zones. And as shown in this diagram, we have workloads in availability zone A, and we are also replicating key resources such as NAT gateway, ALB, and EC2 instances in a second availability zone as well. To achieve connectivity within the single VPC, you may also be using shared VPC today, where you can actually extend some key subnets across many accounts using AWS Resource Access Manager. Again, same principle applies, that is to ensure that you are replicating resources across multiple availability zones or multiple subnets as well as follow the best practices for shared VPC. Now, as you grow, we need to connect multiple VPCs, and we need to connect them to enable communication between various applications. It may be your app servers talking to databases, or it may be your app servers talking to different VPCs, which may or may not be in the same account even. Right? To connect two VPCs together, you can use VPC pairing. VPC pairing allows you to route traffic between two VPCs using private IPv4 addresses or even IPv6 addresses. And instances in either VPCs can communicate with each other as if they are within the same network. Now, key point to note here is that this is only connecting two VPCs. That is, it's a one-to-one relationship, which is non-transitive. And you should also note that you cannot create a VPC pairing connection between VPCs with matching or overlapping CIDR blocks. Now, let's go further, and let's say there is a need for various workloads in multiple VPCs to talk to each other. Using VPC pairing, you can connect these VPCs, but you can imagine how the environment is getting a little complex. How complex, you may be asking? The math is simple. N into n minus 1 divided by 2 is the formula. And let's ask a question. How many number of pairing connections do we actually need to, let's say, achieve a full mesh if we have 10 VPCs? I'll give you a moment to think about it. The answer is 45 VPC pairing connections. Now, you can imagine how this can, overcomplicate your environment, and it wouldn't scale for very large number of VPCs, right? So if you're looking for that large footprint and large scale, how do we solve this problem? The answer is Transit Gateway. AWS Transit Gateway is a network transit hub that you can use to interconnect your VPCs inter or intra-region, as well as on-premises networks using VPNs, Direct Connect, and branches using SD-WAN. We'll actually closely look at some of these designs as we move further in our session today. A quick recap on Transit Gateway. It's a regional construct, it's a regional router, it is highly available, and it scales elastically based on the volume of network traffic you throw at it, right? You can attach thousands of attachments, and then attachments are such like VPC, on-premises connections, and VPNs. It supports key features such as multicast, BGP, GRE support, and it also supports your SD-WAN deployments. Now, routing through a transit gateway operates at layer 3. Now, layer 3, where the packets are sent to a specific next hop attachment based on their destination IP addresses, right? So let's bring that together now. Now we have a production, non-production, or a dev workload in a separate VPC, as well as, let's say, we have a shared services VPC, and it may be hosting like domain controllers or other applications which are central or critical to your IT team. Now, by bringing Transit Gateway into this design, we can connect these VPCs very easily without the complexity of VPC pairing. You can scale it up to thousands of VPCs, right? While Transit Gateway allows you to segment your network by creating multiple route tables, which is very similar to VRF or virtual routing and forwarding in traditional networks. Some customers may actually have further requirements to, let's say, inspect the traffic for east-to-west flows between VPCs or filter out, let's say, egress traffic. This is where you can use the power of Transit Gateway to create an inspection VPC. This inspection VPC may have AWS Network Firewall, which can inspect, filter, or drop the traffic as you need based on your compliance requirements. It may simply be a scenario to, let's say, control access from non-prod to prod by creating an inspection boundary, or it may be an inspection boundary you want to create between various segments of your business or partners. Check out our AWS Network Firewall and Network Security in VPC session, which is delivered by one of my colleagues, Evgeny Vaganov, for further details on it. Now, moving further, as we grow, or as your business grows, you now want to expand to other regions, while still you want to maintain the existing design and features let's say you have implemented in Sydney region. Now, Transit Gateway pairing feature allows you to securely connect to transit gateways in other regions. And using this feature, now you can actually build a global network for your workloads in a matter of minutes. This actually is easily scalable, fully supported by modern APIs for automation. Now, you can imagine you can use CDK, you can use CloudFormation to deploy this and create a global network, right, using transit gateways and pair them together. You may be asking, how secure is that inter-region VPC pairing or transit gateway pairing? So all data which flows across the AWS global network is automatically encrypted at physical layer before it leaves AWS secure facilities. And if you look closely at this diagram, some new generation instance types even support in-transit encryption between the instances. While the traffic for inter-region VPC and inter-region transit gateway pairing is automatically encrypted on our backbone. So follow some of these links on the slides to learn more about these features in details. Let's quickly compare before both options for connectivity between VPCs. We have VPC pairing and we have AWS Transit Gateway. While Transit Gateway can support connectivity between thousands of VPCs, VPC pairing is one-to-one only, and you can support max 125 VPCs pairings per VPC. Transit Gateway supports 50 gigabits per second burst throughput per AZ, but on the other hand, VPC pairing allows you to achieve instance limit throughputs between paired VPCs within a region. And lastly, VPC pairing allows you to use security group referencing, while Transit Gateway does not support it today. Let's summarize. Use multi-AZ architecture and replicate key resources such as NAT gateways, load balancers, any other critical applications for your business in multiple availability zones. Be aware of your VPC quotas before you hit any limits, and use AWS Trusted Advisor to keep on top of this as well. Another key question I get very often is, can you use VPC pairing along with the Transit Gateway? My answer is yes, you can still use inter and intra-region VPC pairing along Transit Gateway. While Transit Gateway actually does allow or does provide you 50 gigabits per second burst throughput, you can still leverage intra-region pairing to achieve instance-level throughput between various resources in different VPCs, or where you need security group referencing, for example. Also, for recurring large data transfer, VPC pairing is also cost-effective, but it does come at a cost of complexity and maintaining routes, pairing connections, etc. Also, when you're using Transit Gateway, make sure you attach it to all AZs which are in use, since Transit Gateway supports 50 gigabits per second burst throughput in each availability zone. Right? Another best practice you can follow is to create a separate subnet for each Transit Gateway attachment. This actually will allow you to keep the inbound and outbound NACLs for Transit Gateway subnets open, as well as it allows you to apply NACLs to your other workload subnets without affecting the traffic which comes from Transit Gateway. Now let's talk about connectivity between your data centers and AWS. In a very typical journey to AWS, initially when you connect to AWS, you would be using your existing WAN provider, or you have, let's say, your private backbone for most of communication, while AWS connectivity hands off as a spoke in your network, with your data centers being the hub, because predominantly your data is going from your site offices into your data centers. As more and more workloads are migrated into AWS, Most of these workloads would be using AWS Backbone now, and AWS regions become the hub, while site offices and data centers become spoke, right? The connectivity between sites to AWS may be via the internet, but you probably want to have a more reliable connection between your data centers and AWS regions for data replication, for migration, etc. So let's connect. Let's connect your on-premises to resources deployed in an AWS region. You can actually use AWS Direct Connect to have a physical connection between your on-premises and an AWS Direct Connect location. You can actually use Direct Connect in 3 different ways. You can connect a public virtual interface to connect to our public services like Amazon S3, Amazon Connect, or any other public endpoint from AWS in the region or globally. We actually advertise appropriate Amazon prefixes to use so that you can reach either your public VPCs, resources, or other AWS services. You can access all AWS prefixes through this connection. You can also connect to a private virtual interface, which actually allows you to connect your on-premises to an Amazon VPC using private IP addresses. And lastly, you can use Transit Virtual Interface or Transit VIF, which actually allows you to connect to AWS Transit Gateway. And now you can reach out to thousands of attachments which are connected to Transit Gateway. AWS Direct Connect allows you to have a very consistent experience as well as reduced data transfer cost. For best practices, if you have a single device and a single data center, your configuration may look like this, where you have a single Direct Connect physical link connecting to a Transit Gateway using Transit VIF, and you can connect to several VPCs. Now, this sort of configuration is probably okay for a dev or a non-production workload because it's a single connection on either side, and there are various failure domains which are applicable. For a secondary or a backup connection, you can also connect your data center to AWS Transit Gateway using AWS site-to-site VPN. Now again, we recommend this approach should only be used for dev and non-production related workloads, as the internet-based VPNs are not going to provide you the consistent experience which is required for critical workloads. You can also use accelerated site-to-site VPN, which uses AWS Global Accelerator to route traffic from your on-premises network to an AWS edge location that is very close to your customer gateway device. We actually look at this feature later in the session a little bit closely and how it can help. Now, you may have a requirement to actually have reliability, but also want to use encryption on AWS Direct Connect. So you can leverage AWS Direct Connect public VIF to establish a VPN to Transit Gateway, which will allow you to encrypt that transit traffic between your data center and AWS. And using AWS Direct Connect public VIF will allow you to have a very consistent experience as compared to connecting via the internet. If you have 2 data centers and multiple devices, ensure that you have physical links to 2 different Direct Connect locations. For example, you can have one connection to Direct Connect location in Melbourne, while other connection can be connected in Sydney, or perhaps one in Perth and one in Sydney as well, right? This will actually allow you to achieve high resiliency for your critical workloads. You can also leverage AWS Direct Connect and Transit Gateway to create a hub for your site offices or data center. For example, in case of a failure of a connection between your 2 data centers, you would like to have a connection between 2 data centers using AWS. Now, in this case, you can use AWS Transit Gateway, Direct Connect, and BGP to create a path which takes the traffic all the way from data center A into AWS, and then all the way back to data center B using Transit Gateway. Now, even though we have multiple Direct Connect to 2 different locations, to achieve maximum resiliency, best practice is to have multiple devices on premises as well as on AWS side. Such topology actually provides you resilience to device failures, connectivity failures, and even complete location failures, right? To wrap up, when connecting Direct Connect, use our resilience toolkit in Web Console to get recommendations on resilience. Based on the choices you make, different SLAs are applicable. So definitely use that tool. Use single AWS Transit Gateway in each region, and use single AWS Transit Gateway globally, since it's a global construct and you don't have to have multiple of those. Another recommendation I have is unique BGP AS numbers. So make sure you use unique ASN numbers between Direct Connect Gateway, and Transit Gateways globally. This will actually allow you to influence the traffic path by various BGP attributes effectively when it comes to traffic manipulation. Now let's talk about best practices to connect your branches to AWS. So when you need to connect your branches to AWS Transit Gateway, you can connect using AWS site-to-site VPN. You only need internet for such connection, and it actually does allow you to enable acceleration to use AWS Backbone as well. Now, we briefly touched on accelerated site-to-site VPNs, which is powered by AWS Global Accelerator previously. I want to take a quick recap on how actually it works and how does it actually helps you there. So let's do that first. So AWS Global Accelerator is actually a network service which you can deploy in front of your internet-facing resources, as well as it powers accelerated site-to-site VPNs, as we talked about that. It actually improves the availability and performance of your applications by using Anycast and AWS Backbone. So let's do a quick feature recap. It does allow you to have a static IP, so no change required to DNS or any external IPs when you're moving the endpoints. It also improves your performance for TCP and UDP applications, which are behind ALB or EC2 instances, and it allows you to failover within 30 seconds, right? So bear in mind that all accelerators are protected by default from DDoS attacks as well, which is using AWS Shield. So why does all that matter? In short, performance, right? The internet rarely goes in a straight line. It can take many networks for your users to reach applications or even AWS site-to-site VPN endpoint, for example, right? Each individual hop or a router in the path can also impact the performance, as each one is a chance for congestion, jitter, or even packet loss, right? Using AWS Global Accelerator, the traffic enters the AWS border network much closer to end user than it previously did. Now, TCP connections are terminated at the edge location closest to your users instead of the endpoint, which actually really accelerate the data transfer globally, right? And for UDP workloads, the AWS network provides the global capacity, which is needed to avoid packet loss and jitter during traffic spikes as well. And again, less network means less kilometers of the fiber cable to travel through, and less routers mean less chance for congestion, jitter, or any sort of packet loss. And this eliminates a lot of that internet weather effect on your applications or even AWS site-to-site VPNs. Let's talk about SD-WAN now, or software-defined wide area network. SD-WANs have long been used to connect data centers and branch offices over the public internet. Today, those networks must also extend to the cloud. However, traditional SD-WAN infrastructure is not always well suited for the task, and it significantly increases the complexity and operational burden because you may be using EC2 instances to have those VPNs coming in all over, right? Now, if your SD-WAN appliance is deployed as an EC2 instance, typically you will have your branch offices connecting via the internet, and there will be some sort of an overlay. It may be like an IPsec VPN or something like that. And your appliances might be maintaining an IPsec VPN to Transit Gateway, right? But the native integration with services like Transit Gateway has been a big ask for our customers. So back in December 2020, we released a new feature, AWS Transit Gateway Connect, which actually allows you to simplify and natively integrate your SD-WAN appliances from our partners into Transit Gateway. It provides like native integration without complex IPsec VPN connections and higher bandwidth interconnects between SD-WAN and AWS Cloud using VPC and Direct Connect as an underlay service, and we'll have a look at that. Now, if you look at this SD-WAN deployment, you can create a GRE tunnel from your partner SD-WAN appliance to Transit Gateway using a VPC attachment as an underlay, which allows you to create a BGP connection between both sides as well now. And now you can use the power of Transit Gateway in a very simplified manner. If you have a SD-WAN appliance, let's say on premises today, you can also use Transit Gateway Connect feature to create a GRE tunnel between on-premises appliance and Transit Gateway to get that native integration all the way from on-premises into Transit Gateway. Now, moving on to our last part, let's briefly take a look at connectivity to and from the internet. When connecting from your resources in AWS to external internet-based resources, it is really important to ensure that security policies are adhered to. And services such as AWS Network Firewall or AWS Gateway Load Balancer, along with our partner firewall or security offerings, they allow you to secure the egress traffic and enforce your policies in a very robust and highly available manner. Now, this architecture can be standalone for, let's say, individual resources in the VPCs, or you can create a single egress VPC which actually act as a single enforcement point for all the egress traffic using Transit Gateway. Ensure that AWS Network Firewall, Gateway Load Balancer, and any other critical resource are configured in multiple availability zones or availability zones where your workload operates. When we talk about connectivity from the internet, same approach should be taken for the ingress traffic from the internet. AWS CloudFront, Global Accelerator, AWS WAF, they can help you secure and improve and accelerate your applications. And services such as AWS Network Firewall and security services empowered by Gateway Load Balancer can actually help you connect and secure the ingress traffic within the VPC. Now, you can turn this into a dedicated VPC when you connect to Transit Gateway and have one central ingress for all of your connectivity from internet need as well. Now, let's bring it all together. Connecting these VPCs using Transit Gateway allows you to scale, establish central intakes, and enforce policies centrally as well. Now, another question I generally get is, should we actually have individual ingress and egress VPCs? My answer would be, it depends on your regulatory framework or what your security posture is. Generally speaking, egress VPCs have different policies and ingress VPCs have different policies and protections, and hence that's a very critical piece of information which you might take into consideration as well. Let's summarize the session. Some of the key takeaways which we've talked about today: use multi-AZ architecture for critical workloads. We talked about VPC pairing versus AWS Transit Gateway and see which fits in what use case. We talked about AWS Direct Connect and multiple virtual interfaces types. And we talked about why it's important to think about resiliency and how you can use resiliency tool to plan for that. We touched upon branch connectivity, how you can use the branch connectivity using site-to-site VPN today, or you can use SD-WAN connectivity using AWS Transit Gateway Connect feature. And in the last part, we actually touched on how you can create central ingress and egress VPCs for traffic to or from the internet. So you've joined AWS Summit to learn, and you can keep on learning beyond the summit with resources from AWS training and certification for networking. We actually offer 15+ free digital courses from beginners to advanced level for cloud architects, network engineers, and even solution architects. Use these courses to learn how you can create AWS and hybrid IT network architectures at scale. Validate your experience with an industry-recognized certification in advanced networking, and take advantage of an exam readiness course. For more information, visit aws.training/networking. With that, I thank you, and please do provide feedback by completing session survey.